right. How far would I have gone up? 500. Very good, Grant. 500. So 500, 2,000 is another point on this line. Up 500, right 2,000 is the same as going up 1 over 4, because 500 is 1/4 of 2,000. I draw that line. And what I'm looking at is shading all of the stuff that is less than or equal to that line, which means that when I shade, I want to be below it. And our feasible region is the overlapping of all of those places. So what we're talking about is the region that's in between the orange and the purple, the pink and the gray. So that means that I'm talking about the region in this quadrilateral that is green. So this green region is the only region that fulfills all of our restrictions that we were talking about. Or in other words, the overlapping of all the shadings. Okay, this one is probably maybe a little bit easier than the previous one. Number 2 out of the 3 examples today. It's probably easier than the other ones. So we always start out again writing down what our X and our Y are. You'll see here that they talk about 2 kinds of ice cream, vanilla and chocolate. So I'm going to make X my vanilla and Y my chocolate. Oh, and based on those, I'm going to talk about the different pieces in here. So we can make a maximum amount of 800 quarts of vanilla a day. So if I look at that, and I'm talking about a maximum of 800 quarts of vanilla, vanilla was my X, that means that my X can't be more than 800. So my X has to be less than or equal to 800. And that was from the statement right here. Maximum of 800 quarts of vanilla. In the same respect, they also talked about up to 600 quarts of chocolate per day. So if I'm talking about the chocolate now, which was my Y, I know that has to be less than or equal to 600. So already I have 2 constraints with that. And then the last thing that they talk about is at most 1,000 quarts of ice cream. So when they talk about the 1,000 quarts of ice cream, that's really saying that the 2 together, the X and the Y, cannot exceed 1,000 quarts. Notice how they didn't mention anything else, so we still have in play those common sense constraints that we don't really talk about very often. Those constraints that we're saying that I know I'm not going to have a negative amount of vanilla, and I know that I'm not going to have a negative amount of chocolate. So in my last graph, I start off with the coordinate axes. This is number 3 now. And in these coordinate axes, as I graph them, we talked about that our X was going to be vanilla. And our Y was going to be chocolate. And the maximum amount that we talked about was 1,000 quarts. So I know I can't do more than 1,000 quarts. So I think when I do my graph, I'm not going to go more than 1,000. So up here would be 1,000, let's say, and then down here would be 1,000. And then since I saw a 600 and an 800 in there somewhere, I think I'm going to go up by 200s. So 200, 400, 600, 800. mean, I could have gone 500 in the middle and that kind of stuff, but this seems to make more sense based on what they told me. So 2, 4, 6, 8 for the vanilla as well. And I think what I'm going to do is I'm going to graph the common sense restraints first, because those kind of are, no big deal. So I know that my vanilla had to be more than or equal to 0 quarts. So the x thing is that vertical line that goes along the y-axis. So here's my first constraint. And as I graph that, I want everything to the right of that because I'm talking about I don't want negative quarts of vanilla. Okay, then my second constraint, which is the second common sense one, I'm going to go with the light blue, even though I did both of them in gray on the previous page. So this one was that my chocolate, which I called y, was greater than or equal to 0, which basically means if I'm looking at the y values, I start at 0 along the x-axis, and I want all the things that are more than 0 because I don't want negative chocolate quarts. So that means all the stuff above that line. And as usual, that means everything in my first quadrant are all the positive values. Next constraint. Let's talk about the vanilla. The vanilla we did in purple. So the vanilla constraint was that our x values, our vanilla ice cream, had less than or equal to 800 quarts. So I go to the 800 quarts for the vanilla, and I draw a vertical line there. And I want everything that's less than or equal to that line, which basically means I want everything to the left. So now, as you can see, my vanilla has been constrained a lot more than the original gray line. And so far, I'm in between the gray and the purple line and above the light blue line. For our chocolate, we had one single constraint, and is that my chocolate quarts had to be less or equal to 600. That was our pink constraint. And basically that means you go to the y value of 600, or in other words on the y-axis, draw a horizontal line. So this is talking about my chocolate quarts. And I want everything that's less than or equal to that, which means I want everything below it. And now as you can see, we've definitely constrained our quarts a little bit more, because now I'm everything to the right of the gray line, above the light blue, below the pink, and to the left of the purple. So in that rectangle right now. So our last constraint was the one that we did in the orange, which said the maximum amount of buckets or quarts that we could make out of this ice cream is 1,000. I'm just going to rearrange that a little bit. When we originally did it, we said that x plus y was less or equal to 1,000. As usual, I'm going to move the x to the right-hand side. So I'm going to get y is less than or equal to 1,000 minus x. That means that my y-intercept is at 1,000. And then I go down one, right one, because that's my slope, -1. Or in other words, if I went down 1,000, I would go right 1,000. Because that's the same as going 1-to-1 ratio, 1,000 to 1,000 ratio. I connect the dots, and this is my last constraint. And I want everything that's less than or equal to that, which means under that line. So now I shade in that feasible part of my graph. And I can see a region that's been cut off by 5 different constraints. And so the corners or the vertices of these constraints are where each of these lines intersect. And inside that region, that's where I will be looking for my solutions that we'll be talking about a lot more tomorrow. So inside of this region right here, in the green shaded area, this is my feasible region.